PMS, pregnancy, menopause. Each stage of womanhood has its unique challenges. That's why Highlands Naturals' new women's multivitamins are formulated with essential daily nutrients, plus targeted support for your life stage. Facing PMS? There's a Highlands Multi for that. Navigating pregnancy and morning sickness? That too. In the throes of menopause, our formula is here to support you through hot flashes and skin changes. Gone are the days of juggling multiple supplements or guessing what you might need. With Highlands Naturals, it's one multivitamin with daily essential nutrients and science-backed ingredients to support you. An all-in-one wellness solution to lighten the load for women? Highlands Naturals is here for it. Find your multi at Amazon or Highlands.com. That's HYLANDS.com. Highlands Naturals. We're here for it.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello, once again, thanks for joining us. This is the Space Nuts podcast. My name is Andrew Dunkley, your host, and with me, as always, is Astronomer-at-Large Professor Fred Watson. Hello, Fred.
Hi, Andrew. Very good to be here. I'm always glad to see your smiling face when we kick off with a Space Nuts recording.
Thank you, sir, and congratulations, episode 250.
Who would have thought it?
When we started, I did not know if this venture would turn into anything, and I'm just so stunned and humbled by the global support that we get. It's been a real joy to connect with so many people, not only via the podcast but via social media. And to be able to swap messages and jokes and just learn a little bit about the people who love astronomy so much, and it's a thrill. And of course, we're not stopping now. It makes it sound like we've come to the end, but we haven't. No, we'll keep on keeping on.
What we're going to do when we get to 1,000, though, when we get to episode 1,000 or 500.
Well, I think by then they'll probably be digging us up to see if we want to do any more.
Speak for yourself. I'm hale and hearty.
Yes.
I've just spent a lot of money on my teeth and my knee. I want to get good value for it.
Oh, dear. And I just built a putting green, and I
know
intend
you
to use that for at least 30 more years.
Yeah.
It's not a waste of money if it's
Quite
just
so.
sit there and look forlorn. Today we will be answering audience questions. That was the original plan, and we've got questions from Cassandra, Ryan, Graham, Paddy and Alyssa, Ralph, Andrew and Mark about all sorts of subjects, but we had one interesting combo question from two different people who don't know each other, but they're both sort of asking the same thing. So we're going to do that as a single double question. Don't ask me how, but we'll play them both at once so that they're talking over each other. Actually, I can do that. But anyway, we'll do that. But first, Fred, some very, very sad news, and that is the death of Apollo 11 astronaut Michael Collins. I heard the news this morning that he'd passed away at the age of 90 after a battle with cancer. And look, he was part of the reason I got so interested in space and astronomy and space travel. I was inspired to go to NASA. As soon as I saw Apollo 11, I always thought, I'm going to go there and see this place and learn more about it. And I think my favourite moment was going to the Saturn V display at NASA in Florida and seeing that Saturn V rocket hanging from the ceiling in its various stages. It was mind-blowing. And, Michael Collins was a part of the reason that happened because, and he's probably part of the reason this podcast is happening, because he was just one of those people that was etched into my mind from a very young age. I saw the Apollo mission at the age of 7. I think you were probably 47, 57 at the time.
Something like that, yeah.
Yeah, and he was a follower of the Space Nuts podcast. I don't know if you or many people know that. I didn't make a big deal of it, but he liked some of our episodes over the last couple of years.
Seriously?
I thought that was, yes, indeed.
I didn't know that.
I was stunned
Wow.
and amazed that he'd paid us any attention at all. So,
Wow.
what a great bloke.
Yeah.
What a great bloke.
Yeah.
And, it's sad, but he lived a long and happy life. And if I could, I'll just read a statement from his family. They say, "We regret to share that our beloved father and grandfather passed away today after a valiant battle with cancer. He spent his final days peacefully with his family by his side. Mike always faced the challenges of life with grace and humility and faced this, his final challenge, in the same way. We will miss him terribly, yet we also know how lucky Mike felt to have lived the life he did. We will honour his wish for us to celebrate, not mourn that life. Please join us in fondly and joyfully remembering his sharp wit, his quiet sense of purpose and his wise perspective gained both from looking back at Earth from the vantage of space and gazing across the calm waters from the deck of his fishing boat." That's a statement from his family, and I think that's lovely, and I think it's a perfect way to see him out from his mortal coil. And I never got to meet him. I did meet Buzz Aldrin. And Buzz, of course, the last of the trio that went to the moon, and that most famous journey of Apollo 11. Yeah, what a great bloke.
Indeed, and just a footnote to that. I was listening this morning to a recording of him. He was giving us a bit of a speech 2 years ago, so it would have been 88, and you would have thought it was a man 40 years younger. He was firing on all cylinders, very, very, very calm, and it was just the same voice that he had when he was in the command module of Apollo 11. Quite remarkable.
One of my favourite stories about Michael Collins, and this is just a bit of trivia that not too many people would be aware of, although I think I have mentioned it once during our time during this podcast. He took a photograph from the module as he orbited the moon while Neil Armstrong and Edwin Aldrin were on the surface. And the photo consisted of the moon in the foreground and the Earth in the background. And at that time, it was the only photograph in history where he was the only human being not in the photo. And, that's pretty extraordinary when you think about it. He took the photo of everybody else that existed in the world at the time.
Yes.
Except for him. That amazed me. It's a piece of trivia, but
it is. It's remarkable.
It's pretty special.
Yeah.
Okay. We will long remember him, of course. Let us move on to our questions. We've got 2 questions. I might just play them back to back, and then we can answer them both together because they both kind of walk the same path in very different ways. These are questions from Cassandra and Ryan. So let's see what they're quizzing us about.
Hey y'all, my name's Cassandra and I am from Tennessee. It's in the United States if you're not familiar with the states. And I just have a really simple and weird question for y'all. Before I ask y'all, I do want to put forth that I am a social studies teacher, so science is not my forte, but I do love learning about space. I'm very interested in space, and I love hearing how you guys take advanced space terms and make them accessible to everyone. So my question was originally put forth by my boyfriend, who is a major space nut, and he's always asking questions that make my brain want to explode. That's what I love about him. But he always asks me if there was a car in space traveling at the speed of light, so assuming a car could survive in space and travel at the speed of light, and it turned on its headlights, would you be able to see the headlights? Let me know what y'all think about that.
That is a really good question. I've heard that before. And Cassandra, there is such a car. It's a Tesla. But before we answer the question, we'll go to Ryan because he asks something not dissimilar.
G'day guys, love your show. Ryan here from Australia. I just want to ask a simple question, if there is such a thing. If you had 2 very fast rocket ships end to end in the vacuum of space and they both accelerated away from each other at the speed of light, but the passengers, well strapped in of course, looking back, would they be seeing twice the speed of light? I know it's a crazy question, but I've often thought about it. So, yeah, interesting. Let us know. Cheers.
Thank you, Ryan, and thank you, Cassandra. And yeah, speed of light questions are always intriguing. And I don't know which way you want to go first, but let's sort of go, okay, a car in space traveling at the speed of light, you turn the lights on. What's going on? What happens then?
So the thing that connects these two questions, Andrew, and they're great questions, and they're the sort of thing that people do think about. What connects them is that you're adding velocities. So with the car headlights, the car's going at it can't travel at the speed of light because only light can do that, but it can be very, very near the speed of light because we do that with subatomic particles. So it's traveling almost at the speed of light, turns on its headlights. The light from the headlights is traveling at the speed of light. So you think, that to a stationary observer, the beam from the headlights must be traveling at almost twice the speed of light. And Ryan's question is the opposite. If you've got two things going away from each other, what is the speed at which they're separating? Is it twice the speed of light if these two rockets are going at almost the speed of light? And the answer is no. And that's because when you get into relativity, and relativity tells us all kinds of very strange things, velocities or speeds don't just add the way we do in the normal world. I'm very reluctant to put formulae into this podcast, but it is actually a relatively simple one. So I'm going to throw it in anyway.
You're pushing the
limits. I know
of adequacy, Fred.
I can do it without it. I mean, basically, the answer is always less than the speed of light. That's what happens.
Right.
So two rockets approaching each other. You expect their closing speed to be twice the speed of light if they're approaching each other, and that works in the world where they're not going anywhere near the speed of light, the normal cars. But when you get to these very high speeds, relativity becomes more and more dominant. And what happens is the addition is not just a simple addition. It's not just one velocity plus the other. It's actually one velocity plus the other divided by 1 plus the two velocities multiplied together divided by the speed of light squared. That's the formula. Don't worry about it. But what it tells you is that, supposing they're both travelling together, closing at 0.9 of the speed of light, if they're coming towards each other, it works the same the other direction. Their closing speed is actually, each one's going at 0.9 the speed of light. They're approaching. You'd expect it to be 1.8 times the speed of light, their closing speed, but it's not. It's 0.99 times the speed of light. It's much closer. If people are interested in this and interested to see the formulae, there are one or two sites on the interweb. Just check out relativistic velocity addition, and it'll tell you all you want to know, probably more besides.
I'll remember that.
Yeah, a lot of it goes into reference frames and things like that we don't want to worry about. But the bottom line is that velocities don't add in the normal way. And there's a practical demonstration of this. We know it happens. We know it works because, as you well know, the two beams of the Large Hadron Collider, which are spinning round between France and Switzerland in opposite directions at very nearly the speed of light, I think it's 0.99995% of the speed of times the speed of light. So they're effectively travelling at the speed of light. They collide them, and the collision speeds are that, an increased fraction of the speed of light, but it doesn't exceed it. So it works.
Yeah, it does. Yeah. So what you're actually saying is that we should change the speed limits of cars to near the speed of light, and we'll be much safer.
Yeah, well, that's right, because you can never go over. It's like, the speed limiter on a truck. It's the same.
You can't exceed it.
But it works in physics. You can't exceed it.
Wow. All right. It's a question I've heard many times, and one that puzzles people. And yes, you'd think if you're travelling near the speed of light and you turn the lights on, that must do something, but it doesn't do anything much.
So
at all.
the answer is yes, you'd see the headlights. But it actually depends on where you were. Clearly, if you were behind it, you wouldn't. But for an observer, a stationary observer, if I can put it that way, you'd see the headlights because the light would be coming to you at the speed of light.
And if we were driving towards each other at 100 kilometres an hour each, our closing speed would be 200, all going apart, same effect.
Yeah.
But at the speed of light or near speed of light, that's cancelled out. It's
not
just
the case. Well,
reached the limit.
It gets progressively slower as you get nearer. The closing velocity gets progressively. It just gets nearer and nearer to the speed of light as the two individual things approach it, but it never exceeds it.
There you go, Cassandra and Ryan. You have your answer, and Cassandra, good luck explaining that to your boyfriend.
What a way to start a Thursday morning, Andrew, with
yes, indeed,
relativistic physics.
Exactly right.
Sorry about that.
No, that's okay. Let's move on to our next question, and this one comes from Graham.
Hello, Andrew and Fred. My name is Graham Murray, and I'm calling from Saltburn by the Sea up on the northeast coast of Yorkshire, England. Saltburn is only 10 miles from Marton, where Captain Cook was born, and a little over 7 miles from Staithes, from where Captain Cook sailed on his voyage that discovered Australia. So in this part of the world, we're very proud of our historic attachment to Oz, and like many, I have family and friends on both coasts down there. Please could I ask you to talk about the moon, specifically the phenomenon of tidal friction? What is the link between water on the Earth and lunar friction, and why only water and not, say, magma beneath the crust? I'm finding online explanations difficult to comprehend, so I'm wondering if your tried and tested communication skills will make this easier for me. I believe on one of the Apollo missions, a parabolic dish was placed on the lunar surface, and that lasers on Earth can be fired at it, reflected back, enabling precise measurement of the distance between the spheres. This has proven that the moon is gradually becoming ever more distant from us. Apparently, back in the age of the dinosaurs, the moon would have appeared considerably larger in the sky. I'm also of the belief, rightly or wrongly, that the presence of the moon stabilizes the Earth's rotation. If this is correct, what are the implications if the moon is becoming increasingly distant? Since discovering Space Nuts, I'm working through the back catalogue. Love everything you're doing and never miss any output, whether on podcast or YouTube. Thanks, guys, if you can help explain it all.
Wonderful. Thank you, Graham. And based on your question, Fred is now going to write his next book in 75 volumes to answer everything you've asked. Before we get to that, though, Graham mentioned Captain Cook, who came from that particular part of the world. And yesterday actually was the anniversary, the 28th of April, of his setting foot in what he named Botany Bay. And Botany Bay is in Sydney Harbour. They tried Sydney Harbour and went, ew. And, or was it the other way around? Captain Phillip.
It was the other way around, actually.
Yeah. Captain Phillip went into Botany Bay after it was discovered by Captain Cook and went,
right.
ew. And then went back out and went into Sydney Harbour and went, oh, this is nice. We'll stay here. What and all. But Captain Cook, the anniversary yesterday of his discovery and setting foot in Botany Bay, he originally named it Stingray Bay for obvious reasons because it was full of stingrays. But after Joseph Banks went for a wander and went, oi, what's all this here then? Which is exactly how he sounds. He brought back all these botanical bits and pieces and they went, wow, this is pretty cool. We'll call it Botany Bay. So, because they found all those amazing plants, including one that's called the Banksia, named after Joseph Banks, of course. So just a little bit of a connection between where Graham is from and why we are here in Australia at the moment. Lunar friction.
There's more to it than that.
Oh, is there?
Well, there's a connection. I know that area very well.
Of course. Oh, yeah. I was going to mention that too, but I totally forgot.
But there is another point that we're always at pains to make here in Australia. And forgive me, Graham, for mentioning this, but Captain Cook did not discover Australia. A lot of people knew about it already.
I wasn't going to split hairs.
No, it's not splitting hairs, really, if you're one of the indigenous people who lived, whose ancestors have been here for tens of thousands of years. So it's a matter of, I suppose, communities coming together rather than discovery, something like that.
Yeah, and if you really do want to split hairs, which I'm going to do now, the first Europeans to discover Australia were actually, was it the Portuguese or the Dutch?
It's the Dutch. Yeah.
It was the Dutch, yes.
Yeah,
I thought
think
so.
so.
They
There's
explained to my
evidence of
wife.
that.
She's Dutch.
Yes.
But yes, yeah, a lot of
Anyway.
people found it. And in fact, here's another piece of trivia. When the
Sorry about
first
this,
fleet
Graham.
arrived, we'll get there eventually.
Yeah.
When the first fleet arrived in 1788, there were 2 French warships off the coast.
Yes. There you go.
They were here going, "Oi, this is ours. You leave." Terrible French accent. I think it turned into Spanish somewhere along the way. They might have been here too. Now, lunar friction.
So I've forgotten the question. No, I haven't. It's okay. Look, Graham, the main thing is, and you kind of put your finger on it in your question, why only water? Well, and why not say magma beneath the crust? And it's everything. The tides actually pull everything around. So the surface of the Earth moves twice a day by something like a foot on average. It varies from place to place. So it's not just the tides going up and down. We are going up and down as well.
That's why I miss those crucial putts. Yeah, it's the movement. It's tidal friction. That's what it is.
Yeah, that's right. The ground's changing under your feet. Fortunately, it's slow enough that we don't get earthquakes. But that's and that's what is also happening on the moon, and that's really the connection. That's where tidal friction comes from, because as the tides raised on the moon by the Earth shift the moon's surface by a small amount, basically that's causing a loss of energy. That's what's stripping the energy from the Earth's rotation. That's why we need leap seconds, because the Earth is very gradually slowing down. It's about 1 millisecond, maybe a little bit more than that, per day per century. So it's a very slow effect. But if you don't do anything about it with atomic clocks, everything gets out of kilter. And before you know where you are, you're celebrating equinoxes and solstices in completely the wrong times of year. So that's the Earth slowdown. And it's actually the same effect, the same phenomenon that is giving rise to this gradual drift of the moon away from the Earth's surface. And actually, those reflectors that you mentioned, Graham, they are what are called corner cube reflectors, and I think the first 3 missions, maybe more than that, placed them on the lunar surface. It wasn't just one of the Apollo missions. These are banks of reflectors, a lot like the old cat's eyes that we used to have in the middle of the road. And what they do is send beams of light exactly back from the direction in which they came. So they've got a 180-degree reversal of the direction, and that means if you shine a laser towards them, you get your laser beam coming back. And modern technology lets you time the flight of the laser beam, which is why we know the distance to the moon with an accuracy of about 1 centimetre. It's extraordinary, totally extraordinary. And that's how we know that I think it's 3.54 centimetres per year is the drift away from the Earth by the moon, which all leads to eventually the two stabilising. The end product of all this is that the moon will wind up about 500,000 kilometres away from the Earth rather than its 1,000 kilometres that it is now. And the two worlds will always face one another. Just as the moon faces the Earth with the same face all the time, the same will be true of the Earth. This is in maybe 10, maybe 20, maybe 40 billion years. It's a long way away. And actually other things will happen before that, but that's never mind. There was one other thing.
I've set an alarm on my watch.
Very good. Well, you might want to do one for the collision of the Andromeda Galaxy with ours, and the sun turning into a red giant.
Already covered.
Already covered. Good. Okay. So yes, that proves the moon. We know the moon's drifting away, and exactly as you said, in the age of the dinosaurs, it was a bit bigger. That's 66 million years ago. So the final. Let me just digress for a minute to explain why the moon is moving away by the same process. And what happens is that it comes about because the Earth's rotation is in the same direction as the moon's orbit, and these things everything's going anti-clockwise from above the North Pole, seen from above the North Pole. So the Earth's rotating, and that carries what we call the tidal bulge around with it. And that's the bulge in the oceans and the crust of the Earth that's caused by the moon's gravity. So that's slightly offset from the direction of the moon. And what that does is it gives the moon itself a slight gravitational tug, which increases its velocity slightly. And if you increase the velocity of a spacecraft, what happens is you move away from the object you're in orbit around. And that's why the moon's drifting off.
Okay.
The final bit is, yes, that we do believe that the fact that the moon is there is one of the things that stabilise the Earth's rotation. And that will continue, I think, even when the two reach their equilibrium point in all these billions of years where each is facing the other. The moon will still be there. It's not going to vanish altogether. It will not be big enough to cause total eclipses of the sun, however. It'll be significantly smaller in the sky than it appears now, which is a rather curious phenomenon, the fact that...
Yes, it's just coincidental that we can observe.
We can see that,
point in
exactly.
Time. Yeah. It's lovely. It's a lovely effect too, and we get to witness it here in 2028. There's going to be a full eclipse, which will see a shadow run right across from the northwest of New South Wales, straight over us, where I am now. Total blackout, and Sydney will get blacked out as well in 2028. Graham, thanks for your question. Great one. And you are listening to episode 250 of the Space Nuts podcast.
Space Nuts.
This is Space Nuts. Andrew Dunkley here with Professor Fred Watson, and a big hello to our patrons, the people who've been supporting us with a couple of dollars a month to keep the vessel afloat, the HMS Endeavour, as we try. That was Captain Cook's ship, by the way, as we try to pass on valuable information in a language that you can understand adequately. But to our patrons, thank you. Whatever way you support us financially, it's certainly appreciated. And if you want to go to patreon.com/spacenuts, you can see how it's all done, or go to our website, spacenutspodcast.com, and click on the subscribe button to find out how you can assist us. We're aiming to become 100% supported by our patrons. And, of course, we need to get the numbers up. So if you would like to become a patron, it's not expensive, and you can choose your poison, basically. But as I've said many, many times, it's not mandatory. So please don't think we are going to make you do this. That's not how it works. It's a volunteer thing. But to those many who have already done so, it's greatly appreciated. So, Fred, let's move on to our next question. This comes from Paddy and Alyssa.
G'day, Fred and Andrew. Paddy here again. My daughter is here with me, and she asks about rainbows through glass, because each time we get home from work, or I get home from work, Alyssa always points out the rainbow on the driveway, and I said to her, it's a light spectrum, I think, dividing the light into different colours, so the rainbow, and then she says, no, it's not. There's a leprechaun. We have to find the leprechaun at the end of the rainbow, and there's a gold. And I'm like, oh, okay, rightio. So what makes a rainbow, and can you explain it to my daughter, Alyssa? Thank you, and may the force be with you. Thanks, guys. Bye.
Thank you, Paddy, and hello, Alyssa. And I'm all on your side in regard to the leprechaun and the pot of gold. I do believe it, and I haven't found it yet, because you can't get to a rainbow, because the more you try to get to it, the further away it gets. It's one of those strange, it's one of those things that they just do to us to make us frustrated, I think. But we had a recent question, Fred, about rainbows from I think it was a bus driver who noticed at certain times in the day it was coming through the edge of his window and creating this incredible effect on the dashboard. And from time to time you do see them. I've seen them with the garden. The sprinkler system in the garden. Sometimes it's a lovely effect, but I guess we can educate Alyssa a bit in terms of what's going on. Well, you can. I'll just sit here and look pretty.
Well, thank God one of us can. Seeing them in the garden is lovely, and this is something I don't tell many people, and. It's the kind of thing that you probably shouldn't tell many people. But when I'm in the shower, Between about October and March, I can see rainbows in the shower.
Oh, wow.
Just from the shower spray, because there's the window in our shower faces east. And it's just at certain times, those certain times of the year, the sun is high enough in the sky or in the right position in the sky to shine on the the droplets of water coming from the shower, and they make a rainbow. You've got to look hard for it though, but it is there.
Yeah.
And that's telling you exactly how rainbows are formed. It's billions of raindrops, and the sunlight passing through them actually is split up into the colours of the rainbow, the spectrum, exactly as Paddy says, and reflected back to us. It's really interesting. What's happening in each raindrop, Andrew, is that the light is going into the raindrop. It's being refracted, that means bent by the front surface of the raindrop. Then it reflects off the back surface of the raindrop, comes out of more or less the same side that it went in, but at a slightly different angle. And the end result of that is that the light is bent actually through an angle of 138 degrees, which means that if you're standing with the sun behind you, what you're seeing is light that's actually coming from at an angle of 42 degrees to the basically to the direction of the sun, where the sun would be if I'm getting, I'm not putting this well at all. It's what we call the antisolar point is the point directly opposite the sun, and it's 42 degrees to the antisolar point. So what you get is this arc of light centered on the antisolar point, the point directly opposite the sun, and it's caused by all these gazillions of raindrops bending light through this 138 degree angle and splitting them into their colours. A very, very complex account, but the bottom line is exactly as you've said. In a sense, a rainbow is an optical illusion, because as you move, the rainbow moves with you. If you went towards one end of the rainbow to dig up the pot of gold, and we used to believe there was a pot of gold at the end of it as well.
I didn't know there was digging involved.
Yeah, you've got to dig.
Manual labour should not be required.
No, in Yorkshire you had to dig for everything. It didn't matter what it was. You had to do something. Aye, by gum. You couldn't just go there and pick it up, So the rainbow, you head towards the end of it where you think the pot of gold is, and the rainbow just goes with you because it's this kind of optical illusion. It's always this 42 degree arc in the sky. They're delightful things. Honestly, I think rainbows are completely magical, and I look out for them whenever I can see them, especially in the shower.
I'm going to ask a question of you in addition to what Paddy and Alyssa have brought up.
Good.
Are rainbows unique to Earth, or could they exist on other planets? And here's another sort of side question to that question.
Yeah.
Let's say you're on a planet where it's raining and it's a blue giant star rather than the colour of our star. Would the rainbow be different?
Yeah. And look, you've hit a point there. The kids' book that I've been working on, it's going through the editing at the moment, and I had a little feature on alien rainbows, exactly what you're asking about.
Oh,
and
how about that?
Yeah, except that the publisher says we haven't got room for this.
Oh no,
should cut it out. So it's going, I'm afraid. I might try and sneak it a mention in somewhere else because it is a lovely topic. I might actually, in fact, I've worked out how to do it, and I'll change it and make it shorter rather than make it as long a feature as it was. But the answer is yes, Andrew. And one place where even in the solar system there might be rainbows is Titan. Saturn's moon Titan, because Titan has a water cycle similar to the Earth's, except it's not water, it's hydrocarbons, it's liquid natural gas. But there are probably, we know because we see clouds, we believe that you would see clouds of droplets of liquid methane, ethane, which is what it is, in the atmosphere, and that would give you rainbows. They wouldn't be as colourful as here on Earth because, as you know, Titan is covered with this smoggy atmosphere, which is like an orange fog. So a lot of the blue light would be taken out. So your rainbow would look predominantly orange, basically. And it's a different angle as well. If I remember rightly, it's 48 degrees, the radius of a methane rainbow, rather than the 42 degrees, the radius of a water rainbow. So, yeah, they'll happen. One of my colleagues, just as a final footnote to this, one of my colleagues from the University of New South Wales and the group that he leads, Jeremy Bailey's his name. He's a very senior and extremely expert astrobiologist. He and his colleagues are looking for the signature of rainbows on other planets beyond the solar system, and you do it by looking for the polarization of the light rather than looking for the arc of light. If you see, because rainbows are highly polarized. If you look at a rainbow here on Earth through polarizing sunglasses, turn your head around, you'll find an angle where it disappears altogether because the light's
Is that right? I'm going to try that. Yeah. Speaking of books, Fred.
Yes.
My clever brother, has come up with this. I don't know if you can see it.
Oh, that's the one. That's the cover.
Yeah, that's the cover.
Yeah, look
put it in the right place. That's the cover of my new book.
Yeah.
He's done a great job. And that'll be out next month. I've just decided to fast track it and get it out there because, why wait?
Yeah.
And I don't have to go through all the rigmarole of editing and convincing publishers I shouldn't put certain photos in the book. I'll just do it myself. But thanks again to Paddy and Alyssa for the rainbows question. Let's move on to a question now from Ralph.
Andrew and Dr. Fred Watson. So this is what it feels like to be near a star. We wake up in the morning, it's daylight, and we take it for granted. We walk outside and see sunlight beaming everywhere, reflecting everywhere, and we feel its warmth on our skin. But what this really is energy rocketing at us from our nearby star. We're exposed to it directly for half of our rotation and are shielded from it during the other half. So this is what it feels like to exist near a star. We look out in the night sky and see billions of other stars, but we're told the universe is mostly space and emptiness. Our only experience is what it feels like to be in the neighborhood of a star. So what's it like to be out in the middle of nowhere, not anywhere near any stars? Is it simply cold and dark and nothingness, or are there faint wisps of energy from nearby galaxies, or dark energy affecting that space, or gravity? Is there anything? We take our existence here for granted so much, I'm just wondering what the opposite would be like, not in the neighborhood of a star. Keep it up, Chief Nuts. Love the podcast, as always. This is Ralph in Northern California, and thank you.
No worries, Ralph. Thank you very much. There'd be no rainbows, I don't imagine, unless you created one yourself. Yep. I think it'd be pretty cold and dark, and it'd be pretty boring too, I think.
It's interesting. And I do have the answer. And actually, you upstaged me a bit there because what I was going to do was put this up in front of the camera.
Exploring stars and invisible planets.
Exploding stars, yeah. It's the US edition of what's called Cosmic Chronicles here in Australia. And the reason I grabbed it before we started, because I knew this question was coming up, is because that is exactly how the book starts. It starts with a typical place in space. And I'm going to, since I've done it already, I'm going to read the beginning of the book. In fact, I might read the first two paragraphs, if that's all right.
This is, fine. This is going to be interesting because Fred has to read his own writing.
Yes, indeed.
Sorry.
Okay, suppose you could come with me to a place that is typical of the universe, a location that experiences the average conditions found throughout the whole of space. Where would we be? On the surface of an alien planet, perhaps, luxuriating among exotic plants and strange, colourful creatures, or close to the brilliant churning atmosphere of a hot star with tortuous magnetic fields funneling lethal bursts of plasma towards us. Oh, what writing. Falling into a black hole, perhaps, or just nowhere. And it's the last of these that is closest to the truth. A typical place in the universe is empty, cold, and dark. And nothing in our experience can quantify just how empty, cold, and dark it is. If you're lucky, you might find 1 atom of hydrogen in the volume of space normally taken up by 15 adults, a cubic metre. The temperature you'd experience is 2.7 degrees above absolute zero, or minus 270 degrees Celsius. That is cold. And to your unaided eyes, the darkness is complete. But don't worry, I'm not going to leave you here. And you've got to read the rest of the book to find out what everything else is like. So it is typical universe, place in the universe, there's essentially nothing. There's the odd hydrogen atom. There's probably dark matter, though, which we can't experience, in any other way than through its gravitational attraction when it gets to large numbers. But we know dark matter outweighs normal matter by 5 to 1. So that means you might find 5 atoms of dark matter, whatever it is, in that 1 cubic metre of space, the average space between the galaxies. Extraordinary.
Ralph, so it is. Ralph's opened a can of worms, but it's okay. There's nothing in it.
There's nothing. That's right.
Great question, though. Really good question, and I kind of figured that's where we'd go with that one.
Yes,
a typical piece of the universe is basically nothing.
Just nothing.
Yeah. Oh, that's kind of like my scorecard after a round of golf. Nothing to write home about. Thank you, Ralph. Appreciate it. And we will take a little break and come back with our last 2 questions on this episode 250 of the Space Nuts podcast.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Thanks for joining us, and hope you're enjoying the latest episode of Space Nuts, episode 250. Now, I mentioned earlier that we're trying to build up our patron numbers to try and self-support the podcast, and that's great if you can do that. But if you want to support us in another way, go to our website, spacenutspodcast.com, click on the shop link, and maybe buy yourself a T-shirt or a polo shirt or a cap or a cup or a mug. I don't know what the difference is between the cup and the mug. They look the same to me, but anyway, there they are. But there's a little tab on the left. This is sort of following on from something Fred just showed you if you're watching on YouTube. It's got books, and they're all in there, all sorts of books that have been put in there. There's Star Craving Mad by Fred Watson. There's Exploding Stars and Invisible Planets by Fred Watson. And a couple of other books that by some virtually unknown author who shall remain nameless. But they're all there. Or you can just check out our catalogue as well. It's all on spacenutspodcast.com. Click on the shop link to see what's what. We can even sell you a couple of stickers. They're cheap as chips. So check it all out. You can support us that way if you sort of don't want to go as far as becoming a patron. So that's an option as well. Now, Fred, 2 more questions to bump off before we call it quits on this episode. And I love this question mainly because I am currently watching this TV series. This is a question from Andrew.
Hey guys, this is Andrew in Victoria, BC. I have a question about the TV show For All Mankind, specifically season 2, episode 1. There is a part of that episode where a coronal mass ejection occurs, and the astronauts on the moon have to basically run to safety. A lot of them get underground or in lava tubes, but you notice a part where the regolith, or the sand on the moon, is actually elevating from the surface, kind of in wave-like fashion. It was quite a sight. I'm just wondering if that's scientifically accurate and if that's something that would typically occur during a coronal mass ejection. I love the show, and thanks for your time.
Thank you, Andrew, and hope all is well in British Columbia. I watched this series, Fred. I was put on to it by a friend of mine, and I've watched, I think we're into season 2, or is it season 3? I think it's season 2. And it's based on the premise that it's one of those alternative history series. They made one where the Germans and Japanese had won the war. That was a great series. I watched all of that. This one's based on the premise that the Russians get to the moon first. They are the first to set foot on the moon. It freaks the Americans out, and the space race changes. So the Americans think, okay, well, they stepped there first, but we'll put the first base on the moon. The Russians have got the same idea, and they put a base on the moon. And then they start thinking, well, we need resources. So they start mining the moon. But the Russians say, well, we're going to do that too. So we'll take your mine. And then they have to fight to get their mine back. And it's really fascinating. I think at the current stage, they're into the 80s. Ronald Reagan is president. The Americans got a base on the moon. And yes, in this particular episode, to start off the latest season, they detect the coronal mass ejection, which is headed straight for the surface of the moon, where the base is, and where the Russians are, for that matter. And the astronauts are all exposed, about 11 of them, I think, on the surface in their suits. They were actually going to watch the sunrise because it was so spectacular, and the coronal mass ejection was minutes away and they had to find cover. Now, as a part of the effect when the coronal mass ejection hits the surface, the lunar regolith, the surface of the moon, ripples like when you vibrate a dish that's got water in it. You get that ripply effect. That's what happened. And Andrew is, of course, wondering if that would be real. Now, as a journalist, I never let the truth get in the way of a good story, or as a science fiction writer anyway. But, I wondered the same thing.
It's I haven't seen the series, I haven't seen the episode, but
it's fabulous.
We were speaking about it earlier, and it's very tempting. Mm-hmm. If ever I get time to watch TV, I'll watch it. And the answer is that it's probably based on fact, because the lunar regolith, the lunar soil, is very, very fine. It's finer than talcum powder, and it reacts to electrical charges. And so we know that from observations made by Apollo astronauts. I think it was Apollo 17. There's a very famous sketch of looking at the limb of the moon, the edge of the moon, from orbit. This is from orbit around, so it's from the command module. You can find it it's probably on Wikipedia, I think. The sketch shows the limb of the moon, the horizon of the moon, just before the sun comes up. So the sun's illuminating from just below the horizon, and all these clouds of material are visible. There's a sort of haze around it. Now, the moon does not have an atmosphere, so it's not an atmospheric effect. And that led to this understanding of something called the levitation of the lunar regolith. And I think there's probably a Wikipedia article on that as well. So levitation of the lunar regolith means that just under the normal solar wind, that the normal effect of the subatomic particles coming from the sun, it charges up the lunar soil so that the particles of soil repel each other. They become charged like charges repel, and essentially float above the surface. It was not visible to the astronauts on the moon. Standing on the moon, they couldn't see this effect happening. But when you see it from space, where there's probably large clouds of this dust being back illuminated by the sun, then it became visible. So it's a really good suggestion that if you have a really intense dumping of charged particles onto the moon's surface from a coronal mass ejection on the sun, a plasma basically being burst out of the sun's photosphere, the surface that we see, you might well get an effect like that. I'd love to see the special effect. I'll try and look it out, actually.
It's really good.
Time. Yeah,
it's really good. What they can do these days is stunning.
Yeah, but it could be possible. Maybe one day we'll find out with cameras on the moon.
Yeah. I've actually found the photo you're referring to. I just did a Google search for levitation of the lunar regolith.
Okay,
and then clicked on images, and there are quite a few photos of the effect or demonstrating the effect. So yes, you can find it quite easily.
Good.
If you're interested in that series, it's on Apple TV, and there's been I'm pretty sure I'm not sure if it's season 2 or season 3, but it's so good. Yeah, I'm way behind. I've got some catching up to do, but it's a really well thought out and clever alternative history storyline that just keeps you wondering where they're going with this. How is this going to end? And I suppose if I want to just be a real nitpicker, some of the movements that they've tried to replicate of the astronauts on the surface are a little bit iffy, but especially when they're walking around inside their quarters, they suddenly look like they're in their own bedrooms because they seem to be moving quite normally, but they're not in spacesuits. So I guess you'd have to wonder, well, maybe that's how they do walk on the moon. But they seem to have become much more sure-footed compared to the Apollo astronauts as well, because they fell over at a rate of knots. But great question, Andrew, and probably some fact to it of some kind. Yes, indeed. Okay, let's move on to our final question for this episode 250. Have I told you it's episode 250? It's episode 250, just in case you were wondering. This is a question from another part of Canada.
Hello, Andrew and Fred. My name is Mark. I'm recording from the city of Sherbrooke in the province of Quebec in Canada. Now, if we want to send a mission to Mars, we have to wait for the correct launch window because of the orbit of the planets, right? Now, does the same logic apply if or when we want to send a probe towards Proxima Centauri? Or can we just aim for the shiny little dot and just go straight ahead? Love the podcast, and please, Space Nuts around the globe, please support the show if you can. Thank you.
Thank you, Mark. Thank you very much for the boost as well. I would think when you're going long haul, it wouldn't matter, but I'm willing to be corrected on that because I don't know anything.
No, you're absolutely right, Andrew. The reason why we have these launch windows with Mars is to give us the minimum energy transfer time between the Earth and Mars. If you had if you had rockets that, if you basically could put whatever thrust you want rather than realistic considerations of fuel and things of that sort, if you could just zap your rocket up to any speed you want, the launch windows broaden, they get much wider. And in a way, when you're thinking about Proxima Centauri, I mean, sending a conventional rocket to Proxima Centauri is a non-starter because it takes you 60,000 years to get there because it's so far.
Yeah.
And the
petrol
only
price would go up too much.
It would. The only practical way to think about it is that, what they're looking at with what's it called, Breakthrough Starshot, the feasibility study for whether you could use a light sail to accelerate a spacecraft to nearly the speed of light and do it in a lot less time. But even then, you're talking about a journey time. Okay, so if you were accelerating up to a third of the speed of light or something like that, you're talking about maybe 13, 14, 15 years to travel time to take into account the accelerations and things. That is a long enough period of time that there have probably been several orbits of the planets of Proxima in that meantime. And, we still don't, we can't actually see these planets directly. So we don't know whereabouts they are in their orbits. We've just got the times that they transit or that they pass in front of the star. We can tell from the wobble of the star roughly whereabouts they are. I guess what you'd be talking about, suppose, yes, there is a spacecraft on its way there. You do what they do with long haul flights within the solar system. You make mid cruise maneuvers. You basically tweak the orbit that you're in by doing course corrections, and you do that as you're approaching Proxima, so that you brought yourself in the best position to have your cameras photographing the planets as you whiz by them, because there's no chance whatsoever of slowing down to go into orbit. It's a bit like when Arrokoth, which we used to call Ultima Thule or Ultima Thule, that object's photographed by New Horizons. The New Horizons orbit, its pathway, its trajectory in space was tweaked in order to bring it within photographing range of Arrokoth. So in it's 2019, I think, so 4 years after the flyby of Pluto. The orbit was tweaked very soon after the flyby of Pluto to bring Ultima Thule, as it was then called, into range. So, that's how you do it.
So, no, you don't need to worry about windows. You just chuck it out there and hope for the best.
Yes, fast as you can.
And we'll see you in 30 years and hope it works.
That's right.
But, thanks for your question, Mark. And thanks to everybody who contributed to episode 250. We got a whole swag of questions, so we got a little bit to work with going forward. Thank you to those people as well. If you didn't get on this episode, listen in for a future episode. We might get to it then. One more thing before we finish up, Fred. Ingenuity flight number 3 has been successful.
Indeed, and we've seen images from the helicopter, colour images, not only of the tyre tracks of Perseverance, which is what we saw from Flight 2, but Flight 3 has revealed the Perseverance rover itself, some 80 metres away or something like that, in the corner of the field of view of the Ingenuity's camera. So exciting stuff. And in fact, I'm not sure where we are with the status of Flight 4. It may even have happened already, but I will follow up on that and make sure. I don't think it has, but I think it's due very soon.
Yes, I think they planned 5 test flights, wasn't it?
There's 5 test flights, that's right. And 4 and 5 were going to be much more adventurous, so they might still be thinking about where to go.
Yeah, I think with flight number 5, they're planning to deliver some pizza. So that'll be a real achievement if they can do that.
I thought it was a book or something.
Can't wait.
No, not pizza. Anyway.
Actually, I read today, speaking of drones and helicopters, Girl Scouts in the United States, again, because of COVID, they can't do the normal door knock to sell cookies or sit out front of supermarkets. One lot's going to use drones to deliver cookies. That's
stuff.
Great.
Yeah,
it's awesome. Just a side note. Thanks again to everybody who contributed. Thanks for listening into episode 250. Don't forget to tell your friends. Follow us on Facebook. Follow us on YouTube. Spread the word. If you get our notifications on Facebook, please share them to all your friends. We want to pick up more and more and more listeners. We want to keep this happy ship flying through space for as long as possible. And Fred, thank you so much. It's been a joy as always, but nice to reach a significant milestone as this 250. Not many cricketers get a score like that, so I feel rather privileged.
Indeed, that's right.
Thanks as always. Yeah.
Yeah. No, I was just going to say, and in case any of our viewers are wondering whether we coordinate our shirts before we start recording these, the answer is no. No, it just happens by accident, folks.
Yeah. I even decided to wear a different coloured jumper, but we're almost matched in that regard as well. But yeah.
Extraordinary. Thank you, Andrew. Always good to talk.
Probably need to talk about this.
Maybe we do. Yeah. All right. See you next time.
Thanks, Fred.
Take care.
All right. See you soon. Fred Watson, Astronomer-at-Large, part of the team here at Space Nuts. And thanks again for supporting the Space Nuts podcast. And thanks to Hugh back in the studio for putting everything together. And we'll join you again next week for another episode of the Space Nuts podcast. See you then. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.